to go over a couple more examples of these. So when we're dealing with inequalities, we need to move everything to one side first. So we're going to have to take, I typically like to put all of my stuff on the left-hand side. Let me switch my blue here. So I'm going to move this over here. To do that, I'm going to have x minus 3 over 4 minus x minus 5 minus x over x, and this would be less than or equal to 0. And before we can set up something so that we can do our sign analysis for this, we are going to have to get common denominators. So our least common denominator for this would be x times 4 minus x. And so that means we would need to multiply this first fraction by x in the numerator and the denominator, and we would need to multiply this second fraction by 4 minus x in the numerator and denominator. And so whenever we do that, in the numerator we are going to get x times x minus 3 minus 5 minus x times 4 minus x all over, and since we have the same denominator here, we can just write this all over the same denominator, x times 4 minus x. And so in the denominator, we don't want to multiply anything back together because our goal is to have this factored. However, in the numerator, I've got this minus sign right here, so I need to distribute and factor so that then I can simplify from there. So whenever we do this, we've got less than or equal to 0 right here. So we're going to have x squared minus 3x whenever we distribute in the numerator there. Let's hold on to this minus sign right here, and let's multiply 5 minus x times 4 minus x first. And so 5 times 4 is going to give you 20, and then you'll have a minus 5x and a minus 4x when you do those inner and outer terms. That's going to give you a minus 9x, and then negative x times negative x is positive x squared, all over x times 4 minus x. So now we need to distribute that negative. So we've got x squared minus 3x minus 20 plus 9x minus x squared all over x times 4 minus x. And so we're going to simplify that numerator so the x squareds are going to cancel, and we will get, we'll move all the way up here, and so we're going to get 6x minus 20 in that numerator over x times 4 minus x, and this is less than or equal to 0. If you want, you could factor out a 3 out of that numerator. It really doesn't matter. It's up to you. I'm just going to leave it like it is. So we finally got this into a form where we can do a sign analysis on this particular problem, and we need to know the values of x that would give us 0 either in the numerator or denominator. So if we do 6x minus 20, we're going to get 6x equals 20, and then x equals 20 over 6, and that will reduce to 10 over 3 there. I'm just going to leave that a fraction. For this section, we'll just have an x equals 0, and then we've got 4 minus x equals 0, so if we move that x over to the other side, we'll get 4 equals x. So we've got 3 values here. We've got this negative 10 thirds. We've got this 0 and this 4. Those all need to go on our number line. 10 divided by 3 here. I may have said negative, but that's not negative. 10 divided by 3 here is going to be a little bit above 3. It's going to be 3.3 repeating. So when we put that on our number line, actually let me put my number line down here to give myself plenty of room. 0 is our lowest value. The 10 thirds will go right here. It'll be a little bit bigger. And then we'll have 4 here. And so I'm going to list all of my factors. I've got 6 minus 20. I've got x. And I've got 4 minus x. And then down here, I'm going to put my answer. And so we're going to set up our chart here. So if I pick a number below 0, a negative number, so for 6, if I pick any negative number here and then subtract 20, I'm going to get a negative. If I pick a number between 0 and 10 thirds, like 1, 6 times 1 minus 20 is still negative. Then after that, if I pick numbers above 10 thirds, then I'm going to get a positive. I could try 11 thirds and plug it in. You can use your calculator if you want there. But I also know 10 thirds was the value that made 6x minus 20 0. So right here it's going to be 0. After that, positive. For x equals 0, that's really simple. If the value is negative, then x is negative. If the value is positive, then you have a positive. And then for 4 minus x, this is going to be a little bit different than some of the other ones we've seen with the chart. Because if I plug in a number below 0, like negative 1, 4 minus negative 1 is actually positive here. And so typically we have been most seen on our chart, you usually start with a negative. That does not happen here. You can see this is written sort of in reverse of what we've seen on the other problems. And that's why you see this happening. So we've got a positive. We're still going to have a positive here. We're going to have a positive here. But if we pick a number bigger than 4, like 5 or 6 or 7, 4 minus 5 would give us a negative right here. So when we look at our answer, here I've got 2 negatives, which is going to give me a positive. Here I've just got 1 negative, which is going to give me a negative. Right here, all positives, and right here, just 1 negative. So I can see I've got positive, negative for my answer. And so for this particular problem, you want to make sure you want to make sure that you're looking right here. It's less than or equal to 0. So that means negative is your answer. However, you do have some excluded values here. So x cannot equal 0 and x cannot equal 4 because either one of those values would give you 0 in the denominator. So we've got an or equal to here, but 0 cannot be an answer and 4 cannot be an answer. So if those end up being part of our answer, then we're not going to include those values because they're going to give us an undefined value for our problem. So we're looking for negative answers, which of course would be right here from 0 to 10 thirds, and then again from 4 up to infinity. So we would not include 0 because it's an excluded value, so I'm going to use a parentheses for my 0, up to 10 thirds. Now it is okay to include 10 thirds because it's not an excluded value. And then from 4 is an excluded value, so I need a parentheses, not a bracket here, and that goes up to infinity would be up here, so to infinity. You can write in inequality notation if you want, but I'm going to put interval notation for this one. So that would be your answer for this problem. Let's do a couple more. All right, this one looks really intimidating at first, but your steps are going to be the same. What you want to do is you want to move all of this over to the other side. So to do that, you're going to have 2x over x minus 5 plus 3 minus 4x plus 1 over x squared minus 6x plus 5. And that's going to be greater than 0. We need to factor this denominator here. In fact, I'm just going to erase and do it because I might run out of room. So right there in that denominator, if I had went ahead and factored that, we would get x minus 5, x minus 1. And you can see right here, you don't have a denominator for the 3, so it would have a denominator of 1. Your least common denominator that you need to use to combine these 3 right here is x minus 5, x minus 1. And so this first term already has an x minus 5, so you're just going to multiply by x minus 1 in the numerator and denominator. for this term, you've got both x minus 5 and x minus 1. So you've got to multiply by both of those in the numerator and denominator. And then this last term already has both of your pieces of your least common denominator, so you don't have to change anything there. So common denominators are the same for all of these. So whatever we have here is over x minus 5 times x minus 1. In the numerator, we've got 2x times x minus 1 plus 3 times x minus 5 times x minus 1. And make sure you have right here minus parentheses for x plus 1, because that negative has to be distributed there. Now, a lot of students have a little trouble right here in knowing what to do. Best idea, multiply your two binomials together first, then you can distribute your 3. If you distribute the 3, you could distribute it first, but you would only distribute it to one of these, and then you would still have to FOIL this out here. So I would multiply these together first. So if you distribute here, you get 2x squared minus 2x plus, and then I'm just going to let that 3 hang out here, and I'm going to multiply these together. So I'll get x squared minus 6x plus 5 when I multiply those together, and then I'm going to distribute that negative there, so minus 4x minus 4. We're not going to lose our denominator here, because on inequalities we cannot cancel out that denominator like we do with our equations. So now we're looking at 2x squared minus 2x plus 3x squared minus 18x plus 15 minus 4x minus 4 all over x minus 5 times x minus 1. And so let's move up here. If we combine our like terms, we've got 5x squared right here. When we put these two together, we're going to have, let's see, that's a minus right there. So we've got a negative 2x and negative 18x and a negative 4x. So that's going to give us minus 24x. And then let's see, those are those 3 right there. And we've got a positive 15 and a negative 4, so that's going to give us a positive 11. And that is all over x minus 5 times x minus 1, and that is greater than 0. Okay, so this one's going to be a little bit more difficult than some of our other problems, because I am not certain, but I do not think that 5x squared minus 24x plus 11 is going to simplify for us. We're not going to be able to factor that. So whenever we're looking at our numbers to put on our number line, I know I'll have an x equals 5, and I know I'll have an x equals 1, but I also am going to have to use quadratic formula to find this. So I'm going to erase my least common denominator here, so I've got a little bit of room. And we are going to use our quadratic formula here to find when 5x squared minus 2x plus 11 would equal 0. So we're going to have x equals 24 plus or minus the square root of 24 squared minus 4 times 5 times 11 all over x minus 5, I'm sorry, I'm looking at the wrong thing there. We're doing quadratic formula. It's all over 2a, not all over the denominator there. So all over 2a is going to give us 2 times 5. And so if we use our calculator here, because we're not going to spend a lot of time with this, then if we do 24 plus, actually let me simplify that just a little bit before I start getting our decimal. So 24 squared minus 4 times 5 times 11 is 356. So we've got 24 plus or minus square root of 356 all over 10. And I'm just going to use the calculator to get decimals for this. So 24 plus the square root of 356 divided by 10 is going to give you 4.287. I'm going to keep 3 decimals there. And then if I do the minus, 24 minus the square root of 356 divided by 10 is going to give you 0.513 here. So these values also have to go on your number line. So when we make our chart here, we're going to have, let's see, our lowest value is 0.513, and then we've got 1, and then we have 4.287, and then 5 here. So we've got lots of values for this one. We are going to have to do 5x squared minus 24x plus 11 as one of our terms, and then we'll have x minus 5 and x minus 1. And room right there. So let me slide that over. Let me slide this right here over a little bit so I've got some room. Okay, so you are going to take some numbers and plug them in to this equation. Now be careful with this quadratic because it's a little bit tougher. Please use your calculator if you get a problem like this. Don't try to do all of this by hand. So if we pick a number below 0.513, we could pick something like 0 would be the easiest. And if you plug in 0 right here, you'll get 11, which is positive. A number between 5.513 and 1 might be like 0.6. So I'm just going to use my calculator real quick to do 5 times 0.6 squared minus 24 times 0.6 plus 11. And it gives me negative 1.6, so I get a negative here. Between 1 and 4.287, I could use a number like 2 or 3. I'm going to use 2. So 5 times 2 squared minus 24 times 2 plus 11 is going to give me negative 17, so that's going to give me a negative here. And then a number between 4.287 and 5, that could be like 4.5 here. So 5 times 4.5 squared minus 24 times 4.5 plus 11 is going to give me 4.25. That's a positive. And then anything above 5, I think is also going to give me a positive. If you think of the shape of the quadratic, it looks like this. It's probably going to be positive from here on out. But you can double check by plugging in a number like 6. If you do that, 5 times 6 squared minus 24 times 6 plus 11 is going to give you 47. So that's a positive value there. So that one's a little tougher to plug in. These others are easier like we have seen. So this is going to change at 5. So it's going to be negative for any value less than 5, but any value larger than 5, it'll be positive. For x minus 1, you're going to have a negative for any value below 1, but at 1, its value will change to positive. So for your answer, you're going to have a positive here, a negative here, positive, negative, and positive. And this particular problem, we had greater than 0, so that tells me we were looking for a positive. And this one does not have an or equal to, so you really don't have to worry about the excluded values. You're not going to include any of your endpoints. And so our positive sections are here from negative infinity up to 0.513. And then from 1 up to 4.287. And then from 5 up here to positive infinity, so 5 to infinity. So this would be our answer for this problem. These are more difficult when you have to do this quadratic formula, but you can still do them. I don't think you'll see a lot of these problems, but you may see some.